Well, hello folks, and welcome to episode 23 of Modular Curiosity. We're going to do a few things today. We're going to talk about sample and holds a little bit more, but we're also going to go back through some things that I missed in previous modules, that is, previous episodes. And I want to show you some things that I was supposed to show you in previous episodes and forgot. So let's go take a look at those real quick. Hey, remember that episode on tides? Let me show you something. Okay, on tides, I kept mentioning that you could use tides as an oscillator, and I never actually showed you how to use it as an oscillator. I always had, I always had the even VCO and tides going to the voltage per octave. And that was pretty wild because I was basically doing extreme FN synthesis there because I was using an audio signal to modulate another audio signal. But I never showed you what the actual oscillator mode is. Okay, so you remember that up here, the top button, if we're on the black or off position, it's in cycle mode. And up here, it's in low for green, medium for, or off for medium, and red for high. Well, let's turn this back on. And what I have is just a Turing machine creating random notes. And you can see that when we're in the red, we are actually in audio range. And the nice thing is we can use our shape, slope, and smoothness to modify the waveform. So right now I'm basically doing a triangle wave. If I want to do a sawtooth wave, how about a reverse sawtooth wave? And you know what? Changing it sounds pretty good. So what if we did something like this to see where's slope, to right there. Kind of cool. But we could also warp the waveform by using the smoothness control. Because remember, if we went to this side, we did some wave folding. And of course, if we modify the shape, we can change the waveform. So let's make it a sine wave. And now let's fold a sine wave. Or let's make it sort of a sawtooth with an exponential rise. So we have a really useful oscillator in addition to everything else that the Tidal modulator or Tides does. Okay, the other thing that I totally missed on the Tidal modulator video, and I have to say thank you to John Melcher on YouTube, who wrote some comments to it and helped me figure this out. It took him a while to figure it out too. But I kept mentioning that the Tidal modulator can have an LFO with a speed as low as 20 minutes. So if we go to the low speed and go all the way down, that's not 20 minutes. And I thought, well, maybe if I go to smoothness, that might do it. And it just sort of flattened the waveform. It didn't really slow it down. Well, John figured out how to make it slow down to 20 minutes. What you do is you take an LFO, square wave, fast LFO, fast pulse wave, take the square wave and put it to freeze. Oh wait, I'm sorry, pulse width, there we go. So basically what you're doing, let's throw up a scope and we'll show you. Basically what we're doing is whenever this pulse wave is high, it's stopping it. And so the smaller the pulse width, the less time that that freeze is off, and that makes it go slower and slower and slower. So we can adjust the time either with this frequency or with the pulse width. There, and that's how we make a really slow LFO, is we keep turning the freeze on and off using a square wave with a very short downtime. So basically that's called the duty cycle of how long is it up, how long is it down. The pulse width is changing the duty cycle. And so that's the trick of how to get really slow LFO times from tides. What else did I miss? Ah, there was something in the MIDI video that I wanted to show you. Let's go look at that next. Okay, so this is a basic setup using my MIDI keyboard, and I'm using MIDI 4, and right now I've got everything set to unison because I'm using one channel and I'm using one oscillator, in this case vowel, because it sounds really silly. But what I forgot to show in the MIDI video are these two columns, velocity and aftertouch. Okay, so velocity puts out a voltage which is high or low, and it changes. It's a changing control voltage based on how fast I hit the key on my MIDI controller. And so I have that going to both the decay and the sustain of my ADSR. So now I'm going to play the key very quietly, very slowly and softly. And I'm going to play hard and fast. Soft. Hard. You can see what I'm changing. Let's get rid of the decay. You might hear it a little better. I'm changing the sustain, which is how loud is the note going to be. So if I play very softly, and I start hitting those keys harder, softer, so I can make VCV rack respond to how hard I play on the keys. So it responds to my technique. And if my MIDI controller had aftertouch, which it doesn't unfortunately, I would also have a control voltage coming out of aftertouch. Now what aftertouch is, after I press a key, if my controller had aftertouch, I could then press harder after the key is already down. And that aftertouch would be used to modulate something else. So maybe I could modulate, say, the LFO frequency. So I could hit something like, and then if I was to press harder, it would. So I could do something like the speed of an LFO or the cutoff of a filter or something that would happen after I've played the chord, but then continuing to press on my keyboard harder or softer, we would pick that up. Unfortunately, my keyboard doesn't have that, but VCV Rack does support it. So that's aftertouch. Now, back to the main point of the video, of this episode, sample and hold. Let's go look at that. Well, welcome back, my friends, to the show that never ends. It's Modular Curiosity with sample and holds on filters. This sound might sound a little familiar. Now, I actually showed something very similar to this in a previous episode, but I've since realized that sample and hold is a lot more useful than simply making Emerson, Lake and Palmer sounds, or making wild computer sounds. Yeah, so what's happening here? Okay, well, I have a clock that's triggering the sample hold. The sample hold is receiving noise as an input. And again, I did talk about noise earlier in another episode. And noise just sounds like that. And noise is really kind of interesting because what it technically is an extremely fast change between every note in the audio spectrum. It's so fast you can almost think of it as playing every note in the audio spectrum at the same time. And so if we filter noise, we get all kinds of interesting sounds. But because it's not exactly every note on the spectrum at the same time, it's actually randomly moving among all the different notes in the audio spectrum. We could basically grab it at any point, and whatever happens at this point where it's triggering is listening to the noise, and whatever random note it happens to be at the very instant that it triggers, sample and hold is going to grab that voltage, because it's just a control voltage, and hold it. So it's going to sample at the time of the trigger and hold that control voltage. And that control voltage we're using to control the pitch of our oscillators. And that gives us a very random sequence. Now, if instead of varying the pitch randomly, we vary the cutoff of a frequency, well, that sounds pretty cool. But what else can it do? Yes, that's the standard use for a sample and hold, but what else can it do? Okay, I was playing with this patch the other day, and I want to share this with you. Let me set it up. Okay, this is just a very strange, kind of cool, ambient, just swirling sound of notes. In fact, I should pan it. Okay, so what's happening here and how is sample and hold being used? Let's see, let's shut down everything except for the first voice. Okay, so what I have right now is a sequencer with 3 different lines of notes. The first one is coming to a quantizer just to keep it in tune. It's coming to the end of my sample and hold. And at this point, I don't actually need the sample and hold. So here's what I'm going to do. I'm going to put the voltage per octave, and I'm just playing the pluck noise out of the macro oscillator, which is braids in the real world. So why did I have it going through the sample and hold? Well, what I decided to use was this sequence as the input to my sample and hold, the output of my sample and hold to voltage per octave, and I'm running the Bernoulli gate on the same gate as the sequencer. So right now with the Bernoulli gate all the way to the left, it's saying every input pass to the output. Every pulse that comes in, because this is just a gate or trigger, pass that trigger through, and it's going to trigger the sample and hold. But as I turn the Bernoulli gate to the right, it will allow fewer and fewer of these pulses through in a random amount. Now, what's the use of the sample and hold? Well, check this out. If I didn't use the sample and hold, hear how the pitch is still changing? So I'm using the sample and hold to literally hold the pitch and save whatever the pitch was at the moment that that trigger passed through, even though the sequencer is still continuing. So I'm really pulling random notes out of the sequencer. And as for things that I forgot to mention, in the real world Bernoulli gate, this black dot is a button. Now it doesn't actually do anything, but if you right click, you can change the channel 1, which is the top, and channel 2 from latch mode to trigger mode. Okay, so in trigger mode, or toggle mode, as it drops out beats from output A, it passes them over to output B. And so right now, this is 100% A. Let's dial it down to about 90%. And what it's saying is that 10% of these triggers pass it over to output A, which right now I don't have anything going to output B. And we can see the little light changing from green for output A to red for output B. What the other mode does is when that switch happens, it says switch everything to output B and now stay there for 90% of the time until I get that 10% change and then switch back. So we'll tend to go A to B, A to B rather than A and then dropping things out. Let's see how that changes the sound. See, so it'll run for a while on A and then a while on B, and it'll randomly switch back and forth, but it'll tend to stay on one channel or the other for a longer amount of time. And of course, we can change the probability that it will switch channels with the knob. I'm going to go back to latch mode. Okay, so what have I done over here? I have another macro oscillator and a resonator. Each hooked to a different stream, a different line of the sequencer. Now I could have each voice randomly turning itself off. And because they're each using sample and hold to hold the note during those times when the gate is not triggering, you have this kind of interesting sound. But here's another thing. What if I take the gate that's triggering this resonator and this macro oscillator and I delay it a little bit? So I'm going to bring them back up so that every note is playing. And I'm going to start delaying first this one. And then this one. And now we'll start dropping out notes using the Bernoulli gate. So now I'm going to drop out a lot of the notes, which is going to make it very sparse, but I'm going to speed up the clock. And because these triggers are delayed, they're not happening at the same time. And of course we could play with things like the resonator of what's the tone we're going to give. And then just for fun, I fed 2 of them through clouds. And of course, we have a whole bunch of sounds in the macro oscillator, so we can switch between. But I kind of like the plucking sound. Well, that's it for Modular Curiosity episode 23. Thank you so much for watching. And as always, if you enjoy these videos, please like and subscribe. That always does help me out. Hey, do you realize we hit over 1,000 subscribers? How cool is that? Thank you very much. And as I always say, remember, stay curious. All right, folks, see you next time.